the session, they will be able to.
Absolutely. Okay, so are we back on to the PowerPoint with everybody?
Yeah, I can see it.
Okay. Should be just our home screen, gas heating diagnostic module number 1.
Yep, we can see it too.
Okay. Well, again, team, we are recording the session, so I've got 1 minute till the top of the hour, and again, I'd like to welcome everybody to our training program today. And as Jill said, if everyone will please mute your microphones, and then if you do have questions, or at the obvious places I will ask for questions, I'll solicit questions, and go ahead and unmute your mic, ask your questions, then mute it again. And that way it'll prevent some of that echoing that Jill was talking about. So Jill, at this point, we'll go ahead and kick off anytime you're ready or whenever you want. If we've got everybody, we'll kick off when you say so.
I would say go ahead, Joel. If somebody else tries to join, will you get a notice so that you can let them in?
I believe if they've got the link, it should just bring them right in.
Okay, perfect. Then I say go for it.
Okay, well, again, thanks again for the opportunity, everybody, to train this afternoon with everyone. And so we're going to have a little PowerPoint presentation. Today, we're going to be doing gas heating diagnostics module number 1 and 2. Now, what we've done, Jill and I have worked together and collaborated to build some training programs and modules. And we can present these modules one at a time, but typically in our little 2-hour session, we find that we can do 2 modules in an afternoon, and then next week we'll do module number 3 and 4 as we got kind of messed up with our schedule with the hurricane and stuff down here. So we're going to be doing gas heating diagnostic module number 1 and 2 today. So we'd like to welcome everybody to the program. Some of the key things we're going to be talking about today. We're going to talk about vestibule layout for both an 80% and 95% furnaces. And by the way, the furnace products we're going to be talking about today will be both single stage and 2-stage gas furnace products. We're going to talk about a single stage ECM control board layout and the connections, as well as a 2-stage ECM control board layout and connections. So we're going to literally go over every terminal, every input, every output on the board. So we want to make sure everybody fully understands how the furnaces work. We'll go over sequence of operation and stuff a little bit later on this afternoon. But for now, let's go ahead and kick off with just a quick vestibule layout of the 80 and 95% furnaces. So if you remove the service panel on our typical 80% furnace, now this 80% furnace is going to be a furnace that is not rated with the PVC pipe. In other words, it's going to be a metal vent. And so if you remove the service panel, this is actually what you're looking at. So let's go ahead and take a minute and look at all the key components. And again, I'm sure that everyone knows what a furnace looks like, but just to make sure everybody's singing off the same page of music, so to speak, let's go ahead and just do a quick layout of the furnace as we review each key critical component. So starting at the top, there's our vent connection. And again, this is a metal vent because it's an 80% furnace. And there's our induced draft blower housing, our inducer blower housing that's going to get rid of all of our combustion products. There's the pressure switch. Now you'll notice it's not unusual on our 80% furnace. Quite often we'll actually mount the pressure switch right on the induced draft blower housing. It's a convenient place to mount it, but it's also a spot where it's going to read directly from the induced draft blower housing as far as your vent pressure. There's our hot surface igniter that's going to sit behind the gas valve. The dead giveaway, there's going to be 2 white wires going to it, and it's going to be a hot surface igniter, a type of hot surface igniter. There's our gas valve. Now remember, team, this gas valve could either be a single stage or 2-stage or a modulating gas valve based on the furnace product that you're looking at. We move around to the right-hand side. There's the manifold from the gas valve down to the burner assembly. Here we have our in-shot burners. Now it should be noted that all of our Champion products feature in-shot burners. On a propane conversion, please make a note of this. If you're going with a propane conversion, we do have stainless steel version or stainless steel burners available, and we recommend that if you do go to a propane conversion, to go ahead and add the stainless steel burners as an accessory, because I think the stainless steel burners, they hold up a lot better, especially with propane. As we look closely in the picture, we also see that we've got some rollout switches or switches And that based on the size of the furnace, you may have either 1 or 2 rollout switches. Here's our flame sensor. Now, team, the dead giveaway that you're looking at a flame sensor is it's the only component on the furnace that has that single purple wire. So the single purple wire goes to the flame sensor, and it's going to be on the opposite side of the burner assembly from the igniter, from the hot surface igniter. There's our line voltage connection box. This is where you'll bring power into the furnace, your line voltage. And then finally, there's our primary or our high limit. Now remember, team, that high limit's going to be sensing vestibule temperature as that hot air goes across the heat exchanger and warms up. This is going to be sensing that hot air in the heat exchanger area. At this time, team, go ahead and unmute your mic. Is there any questions or comments on the basic 80% vestibule layout before we continue?
No.
Is everybody good? Okay, well, let's go ahead and continue with our little slideshow at this point. Here's a 95% furnace. And when I say 95%, team, this is going to be a condensing style furnace. Any of our condensing style furnaces are going to make at least 95% efficiency. And actually, based on the furnace model that you're looking at, specifically, we actually go up to 98% efficiency on some of our models. So very, very efficient furnace. It's a great furnace. It's also a condensing furnace, which means that it's going to have condensate that's going to be running anytime it's in the heating mode of operation as part of our high efficiency process. So starting over here on the left-hand side, there's our line voltage connection. There's a 4-way collector box. Now, team, this is very, very interesting. So our furnaces, all of our champion furnaces are 4-way convertible. And by the way, they all stand 33 inches tall. And one of the neat thing about our 95% plus furnace is the fact it's also 4-way convertible. And the way we can do that is because we have a built-in 4-way convertible or 4-way internal trap and draining system. So what this does is this allows you to take your furnace and lay it horizontal, left or right, vertical, upflow or downflow, and then just reconfigure a few hoses. You don't have a bunch of complicated traps. You don't have a bunch of extra parts you have to deal with like our competitors do. And you know, with a bunch of stuff hanging outside the cabinet, you just have a little simple drain line going out. So it's really, really nice that we can trap the furnace, the condensate, inside the cabinet with this patented 4-way collector box. It's a Johnson Controls exclusive, works very, very well. And again, you know, not to beat up the competition, but you know, with our furnaces, you just buy any of our furnaces and they're 4-way convertible. You don't have to worry about, you know, like some of our competitors, you have to worry about, oh, let's see, I got to buy a downflow furnace and lay it to the left, and then I have to buy an upflow furnace and lay it to the left to blow the other way, and so on. You don't have to worry about all that. So all of our furnaces are 4-way convertible. Any questions or comments on that so far? Okay. Well, there's a block drain switch because it is a condensate producing high efficiency furnace. You're going to have a drain. You're going to be draining condensate anytime it's heating. So there's a block drain switch. Right beside it, there's a combustion air pressure switch. It's going to be proving venting of the combustion motor or the induced draft blower motor. Here we've got our combustion air connection, our inlet at the top. We have rollout switches on our burner assembly. Again, you might have more than one based on the size of the furnace. And by the way, team, there are those little switches that just have a little push button. It's a little push button reset. So a technician has to reset that. If you have a rollout condition, we want to make sure the technician looks at it and resets it. It's a manual type of reset. There's our burner assembly. Again, it's an in-shot burner, and stainless steel burners are available for propane conversion. We highly recommend that, stainless steel burners. There's our igniter, again, sitting behind the gas valve. There's our gas valve, and again, team, that could be a single stage, 2-stage, or modulating gas valve based on the furnace product that you're looking at. Here we have our flame sensor, and again, across all of our furnace line, it's easy to identify the flame sensor. It's the only component that's got the single purple wire going to it. There's our primary high limit. Again, that's going to be sensing the air temperature. There's our vent connection. Now, it should be noted, team, on our condensing style furnaces, we have what we call a rain gutter feature, You'll notice that on that vent connection, there's going to be a little black hose coming down and draining water off there. And what that does is if you get any condensate coming down the vent pipe, it'll collect in that little rain gutter and it'll go down the drain. So it's a real nice little feature. It prevents condensate coming down the vent connection getting into the induced draft blower. So it's a real nice feature that we call a rain gutter. It actually removes that condensate from the vent pipe. There's our induced draft blower. Finally, again, look at that simple drain line coming out. You don't have a bunch of complicated traps. You don't have a bunch of, unusual way to vent the thing and to drain it out. You just have that little simple drain line coming out there. Very, very easy to install and configure. Just a great, great product. Any questions or comments on the 95% layout before we start getting into some control boards and some other things? Any questions or comments? All right, team. Well, I'll tell you what, then let's go ahead and start looking at some of our control boards. Now, again, we're going to literally go over every terminal, every input, every output, and talk about everything on the board, all the key features of the board. Now, one of the things you're going to notice, team, we've taken all of the wires off the board. This is just a bare board to look at. And so all of our photos are going to feature just a bare board with no harnesses on it. Because remember, team, from the factory, there's going to be all kinds of harnessing already hooked up to the board. The technician doesn't have to hook all that up, but we've removed all that harnessing and all the wires so that we can talk about all the features of the board. And so as we kind of go around the board, if you've got questions or comments, or if you'd like, just make sure and take some good detailed notes on what we're looking at. But please stop me if you've got a question on any of the board features as we start talking about the boards. Now, it should be noted this is a single stage heating board, but it's also two-stage cooling capable. So I want to say that again. It's a single stage heating, but it's a two-stage capable board for on the cooling side, a two-stage cooling capable. This is the control board you're going to find on your TM8 or your TM9E furnace. That E means it's a high efficiency motor, and it's capable of two-stage cooling operation. This is pretty cool. And not to beat a dead horse to death, but I'm telling you, this is a great, great furnace. This furnace, we sell a lot of these with our Wind Supply locations. And this furnace is very, very versatile. You can hook this thing up to any product up to 19 SEER. It literally hooks up with anything in the inventory except the very high-end Momentum 20 and 21 SEER products. So if you want to take this furnace and you want to hook it up to a 19 SEER or a 17 SEER two-stage, it'll work absolutely fine. So very, very versatile product. I like this furnace a lot. So starting in the left-hand side, we're going to talk about our low voltage terminal strips where we're going to actually hook up our thermostat wiring to. So Y1 is your first stage cooling call. Y2 is your second stage cooling call from the thermostat to the board, commanding second stage airflow for cooling. W is your heating call. Now remember, team, because it's a single stage heating board, you're only going to have one W terminal. So a W terminal is your heating call. R terminal is your 24-volt hot. G is your fan call. And C is 24-volt common. So you'll notice it's pretty conventional as far as the industry is concerned. You know, Y1, Y2, W, R, G, and C, very, very straightforward on the low voltage wiring. Any questions or comments so far? Okay, well, let's continue with our tour, if you will, around the board. Here we have a continuous fan on speed selection. So this is pretty cool. This is something unique about the Champion furnaces that I really like. So instead of just having, you know, if the homeowner goes to the thermostat sub-base assembly and they take the fan switch on the thermostat from auto to on, normally the fan will run at cooling airflow on most of our competitors' products. But what we do with this jumper where it says fan speed, we give you the option of a continuous on fan. If the homeowner is selecting just the fan to run by itself, you'll notice that you can either run the fan at low cool or high cool or heating speed. And so this gives us the option of giving you some some continuous fan speeds for constant filtration in the home, which is a real nice feature, especially now with COVID-19. People are more and more interested than they've ever been, in clean air products. And the best way to keep that filter working is to keep air moving across it. But a lot of times it's inconvenient to have full cooling airflow, just for air filtration. So this gives us some real nice options of allowing us to have either low cool, high cool, or heating speed on the fan for continuous fan on operation. So that's a nice little feature of this board. Right above that is our heating blower off delay selection. Now what this is, team, so when the furnace has completed its call for heating, the fan continues to run to distribute that heat that's left over on the heat exchanger into the conditioned space. So how long that fan runs is going to be determined by that jumper right there. You'll notice that it goes up to 180 seconds and all the way down to 60 seconds. And the factory setting is normally around 120 seconds. And so, but it is selectable. It's field selectable. The heating off delay is field selectable from 60 to 180 seconds. And again, team, this is how long the fan runs after the call for heat goes away or after the thermostat is satisfied. Any questions or comments so far? Is everyone good? Okay. Here's our last error button. This last error button allows you to retrieve flash codes off the board, and the board will remember the last 5 errors. So if you hold that last error button down about 10 or 15 seconds, it will clear the memory, and it's real convenient for the technician to be able to find out what the flash codes are. If he has flash codes or if he's having issues on the board, he can retrieve those by utilizing that last error button. Jill, would you do me a huge favor just to make sure that the audio and stuff is going good? Everybody's awful quiet out there. Can you still hear me okay and see the PowerPoint?
Yep, I can hear you fine.
Okay, all right. We just have a real quiet bunch today. I hope
it all in.
Okay, they're just soaking it in. All right, well, fantastic. All right, so that's our last error button. As we move around the board, team, we've got our LED. This is our status LED that will allow us to retrieve flash codes. Now remember, team, that LED will either be green, red, or yellow. And actually, if you look in the service information or if you look at the service manual, I think they call it amber, but I call it yellow. It's the same thing. So that flash code or that LED, it's a tricolor LED. It will flash either red, green, or yellow based on the flash code. As we move around the board, we see we've got some 24-volt motor connections because remember, team, we've got an ECM type of motor. So here's the principle behind all high-efficiency motors on our product. We have line voltage to them all the time. So anytime the furnace is plugged in, there's line voltage on that motor. And then that motor is just sitting there waiting for a 24-volt command from the thermostat or from the control board to tell it what to do. So all of our ECM motors, all of our high-efficiency ECM motors are designed to have power to them all the time, and then you command it and tell it what to do with the 24-volt signal. So this is part of our 24-volt motor hookup. You have a terminal, you have what we call terminal and park, as well as G terminal output. So if you take a look at our schematic, you'll see that park is going to be for unused motor windings. You'll have 24-volt common, then you'll have a separate little terminal where it says 24-volt AC motor right there for G for a separate G speed other than low cool, high cool, or heating speed. If you just have G, it's going to be about 50% airflow. So that's some of our motor inputs right there. As we come down on the right-hand side of the board, we see we have a low cool, a high cool, and a heating speed. And these also are 24-volt motor taps that go down to the speed selection on the ECM motor. So remember, team, the ECM motor has power to it, line voltage all the time. Then we're going to command it and tell it what to do with 24-volt commands. So please remember, this is going to be our 24-volt command, low cool, high cool, and heating speed, going down to the motor speed tap selections, based on setting up the motor and what speed you want for high cool, low cool, and heating speed. Now, right below that, we have what we call an EAC terminal. The EAC terminal is electronic air cleaner. Now, please note, it's 120 volt AC. Now that EAC means electronic air cleaner. So anytime you're getting a fan operation, you'll have 120 volt on that EAC terminal for an electronic air cleaner if your unit is so equipped with electronic air cleaner. Right below the EAC terminal, you're going to find there's a 120 volt input. And this is our L1 120 volt input that's going to be feeding the 120 volt components on the board. So this is where the power actually comes into the board to feed those key components like transformers and power all the time to the ECM motor and so on. So L1 is 120 volt input. XFMR is 120 volt input to power up the transformer. So again, this is where you're going to power the transformer. We've got a terminal on here that goes to one side of the transformer, the primary side of the transformer, to power up that 24 volt transformer. This is the power side, the high power side. Here we have 120 volt line. And what this is, that line is actually that 120 volts that's going to be powering up the ECM motor all the time. Because remember, team, again, on an ECM motor, anytime you have power to the furnace, that motor is powered up and it's just waiting for an input, a 24 volt input, to tell it what to do. Right below the line that powers the motor up, you're going to have a HUM terminal, HUM, that HUM terminal. What that is, that's 120 volt humidifier output. And that's going to allow you to power up a humidifier anytime you have a call for heat. So anytime you get a W call to the board, it's going to look at all the the safeties and the pressure switches and so on. And once you have a legitimate heating call, it'll go ahead and power up that humidifier, that you can run a humidifier from that 120 volt output from the board for humidifier operation. Now, right below it, you're going to notice there's kind of a little block down there, if you will. Just look at the red block. Those are all your neutrals. Those are 120 volt neutral terminals, and they're all tied together. So your white wires from, the white wire from your transformer and your ECM motor, basically this is where your white wires are going to hook up your neutral terminals on the 120 volt neutral components on the board. Now, right below the neutral terminals, you're going to have a harness. Now, remember, team, this is going to be harnessed up from the factory. We've just removed the harness so we can talk about it in our training today, but this will be harnessed from the factory. But this is the output to the hot surface igniter, which is a 120 volt hot surface igniter, and the inducer fan motor. And so that harness is going to be feeding that power right over to those two components. Now, this is a really neat feature. Right next to that harness, you're going to find there's a flame current pad. Now, team, every one of our Champion furnaces features a flame current pad. And what that is, it's a really neat little feature that allows you to read flame current directly on the board without having a special meter. As a matter of fact, if a technician will take his normal volt-ohm meter and go to DC volts, he goes to DC volts. So instead of having to have a special flame current meter, we build this in right on every one of our Champion control boards. And so all he has to do is he takes his normal voltmeter that he uses every day, and he goes to DC volts, and he takes his meter leads and he goes to those little terminals right there on the flame current pad, and then 1 volt DC on his voltmeter. If he goes to the DC scale, DC voltage scale, 1 volt DC equals 1 microamp flame current. 1 microamp flame current equals 1 DC volt. Now, please write this down and please make a note of this. Normal flame current on our furnaces are typically from about 3.5 to 4. About 3.5 to 4. If the flame current starts to fall down because you got a dirty flame sensor or you have poor grounding on the furnace, those are a couple of the main reasons you'd have low flame current. But if you have low flame current, in other words, if the board senses 1.5 microamp flame current or less, it'll start flashing an amber or yellow flash code. So it'll flash you a flash code if you have low flame current. If it gets below 0.1, it'll lock the furnace out. So let me say that one more time. Typical flame current with normal running operation is about 3.5 to 4. At 1.5 flame current, you start generating a flash code that says, hey, I'm starting to get low, a yellow flash code. but at 0.1, flame current, it locks the furnace out. Any questions or comments on that flame current pad and how we could use that to check our flame current when we do our service work on the furnace? Okay. Again, every one of our Champion furnaces features that flame current pad. It's a really cool, slick service feature on all of our furnaces. Okay, there's a 3-amp fuse for 24-volt onboard protection. So all of our 24-volt circuitry on the board is protected by that 3-amp fuse. And then here's a 12-pin harness. That 12-pin harness are 24-volt inputs and outputs. And again, this is going to be harnessed in from the factory team. We just took that harness off so that we could talk about it. So that 12-pin plug is a 24-volt input-output to your gas valve, and your safety switches and your pressure switches will all be harnessed in right there on that 12-pin harness. Any questions or comments on that, on the single-stage board layout, before we jump into another board and look at some of the key features on a 2-stage board, which will be next? Any questions or comments on our single-stage board layout, which we'll find on a TM8 or a TM9E furnace? Everybody good? Okay, well, if you'll please follow along then, let's talk about our 2-stage board layout, a 2-stage board. Now, this 2-stage board is going to be found on a TM8 or a TM9Y. Now, we sell a lot of these furnaces as well. This is a really good furnace. Again, like our previous furnace, this is a very, very versatile furnace that will hook up to anything in our inventory up to 19 SEER. So you can use it on a single-stage furnace. You can use it on a single-stage unit outside. You could use it on a 2-stage cooling unit outside. Anything in our inventory up to 19 SEER. Oh, and by the way, while I'm thinking about it, on our TH16, our 5-stage heat pump, our TH16, you could use this on a TH16 as well, and which makes it, again, very, very versatile if you want to do like a dual fuel with a TH16. Very, very versatile product. So just like we did before, team, we're going to start out on the left-hand side with the low voltage terminal and just have a quick review of where we hook the thermostat up, and then we'll go over to all the features that we have on the board from a technical standpoint. So over on the left-hand side, Y1 is first stage cooling, and again, this board is 2-stage cooling, 2-stage heating capable board. So 2-stage heating, 2-stage cooling board. Well, by the way, that Y means it's a high efficiency. This also has a high efficiency blower motor in it, a high efficiency ECM type of blower motor. So Y1 is first stage cooling call from the thermostat. Y2 is our second stage cooling call. W1, W/W1, I should say. We have it silk screen, W/W1. And team, please make a note of this. You always bring W/W1 to this W1 terminal. Now, the reason we have a double label on it is if you're stuck with a single stage thermostat. Let me say that again. If you're stuck with a single stage thermostat, or maybe you don't have enough wires behind the wall, you can still use this control board with a single stage thermostat. Let me say that again. You can use this 2-stage control board with a single stage thermostat if you're stuck with a single stage thermostat, or if you're stuck with, you don't have enough wires behind the wall, and maybe the contractor, he hasn't bid, replacing the wire, or maybe can't get to the wire. So if you don't have enough wires, you can still use this 2-stage control board, or this 2-stage product on a single stage thermostat. It's the coolest thing. But make sure that if you've got a single stage thermostat, you take it to the W1 wire, the W/W1. That's why we put W/W1, because the W means that if you're stuck with a single stage thermostat, that's the terminal you use. So W/W1 is first stage heating call. W2 is second stage heating call. R is 24 volt, just like we had before, team. That's very, very conventional. G is our fan call, our fan on call for fan operation. and C is 24-volt common. And so again, very, very conventional in our low voltage wiring, very conventional in the industry as far as, Y1, Y2, W2, and so on. Any questions or comments on the low voltage wiring before we move on? All right, team, as we move around the board, there's our last error button. And again, if you push that error button, you can retrieve the flash codes, your last 5 flash codes. And if you hold that error button down for about 10 seconds, it'll clear the memory. You can kind of refresh that memory, the technician, if he wants to clear that memory after he looks at those flash codes. Right next to the last error button is our status LED to retrieve those flash codes. And again, this is a tricolor LED. It will flash either yellow, green, or red based on the flash code. As we move around the board, here's some continuous fan on speed selections, which is pretty cool. And again, if the homeowner goes to the thermostat sub-base assembly and they go from auto to on the fan, how fast does the fan run? That's what those jumpers are for. And you can see based on those dip switch selection, I said jumper, but it's actually dip switches on this board. Based on those dip switch selections, you can run either low heat or high heat for continuous fan, low cool or high cool. So again, very, very nice if you have some clean air products and you want to continue letting the air circulate through the home. Here we have our blower off delay selection, our blower off delay. And again, what this does, it allows us to select how long the fan's going to run after the call for heat goes away. So once the thermostat is satisfied on a heating call, the fan continues to run 60 to 180 seconds based on the location or the selection of those dip switches. Team, this is a really, really cool feature. We're going to spend a little bit of time on this. This is a really cool feature on our TM98 and TM9Y boards. What this is a staging, this is a second stage staging selection if you're stuck with a single stage thermostat. That's why I was stressing that if you have a single stage thermostat, be sure and hook it up to the W/W1 wire if you have a single stage thermostat. Because if you're stuck with a single stage thermostat, we can still give you some staging function with these dip switches. Now watch this. If both of those switches are in the off position and you're stuck with a single stage thermostat, you don't get any second stage staging at all. Or if you look at the numbers closely, you'll see you have 10 minutes or 20 minutes. So based on those dip switch selections, you can select, again, this is if you're stuck with a single stage thermostat. If you put it on 10 minutes and you get a call for heating, if the call for heat is still there on W after 10 minutes, it'll automatically go to second stage. If it's on the 10-minute selection, it'll go to second stage to satisfy the call. If it's on 20 minutes, same thing. If you got a W call to the board and it's still calling for heating after 20 minutes, it'll automatically go to second stage. It'll time out 20 minutes and it'll go to second stage to finish the call. So you have 2 time selections, 10 and 20 minutes. The third selection is what we call auto, A-U-T-O, auto. In the auto position, now watch this. In the auto position, now again, team, this is presuming you're stuck with a single stage thermostat. If you're stuck with a single stage thermostat and that those dip switches are in the auto position, what will happen is the board will start looking at thermostat activity. In other words, how long does it take for the thermostat to satisfy a call for heat? It might be 7 minutes, it might be 10 minutes, it might be 12 minutes, whatever. And so what it does, the board starts looking at how long it's taking that thermostat to satisfy on a heating call. And then what it does, it makes intelligent decisions at the board level. It makes intelligent decisions on when to stage second stage. It's the coolest thing. So I highly recommend if you're stuck with a single stage thermostat, be sure the dip switches are in the auto position and then let the board make intelligent decisions on when to stage based on thermostat activity. Any questions or comments on that auto function or any of the functions we've talked about so far? That's one of the things I really love about our Johnson Controls products. We can let the board do a lot of really cool things based on our features and so on that we have on the board. But any questions or comments so far, especially on that auto function if you're stuck with a single stage thermostat? Was that well explained? Is everybody good?
I have a question.
Yes, please.
Jump Y or not, W1 and W2 for that or not?
I didn't hear the question clearly. Please repeat it.
Would you have to jump W1 and W2?
No, that's a great question. That's a good question. So basically the board is smart enough that if it only sees a W/W1 input, it automatically presumes that it's stuck on a single stage thermostat. So good. You do not have to jump for W1 and W2. So what you're going to do, you're just going to bring power. If you're stuck with a single stage thermostat, you just bring it into W/W1, and then the board's going to look at those dip switches for staging function. Now, if you have a two-stage thermostat, two-stage heating thermostat, and you bring in W/W1 for first stage heat and then W2 for second stage heat, if the board sees a W2 call, it ignores those dip switches. That was an excellent question. Any other good questions or comments? Good question. All right, team, well, let's continue our tour, if you will, around the board. Here we have our blower speed tap selections. Again, this is a high efficiency motor, and you'll notice we've got it like a park terminal and some high heat, low cool, and so on speed selections. And like any ECM type of motor, high efficiency motor, it's got power to it all the time, and the board will generate 24 volt outputs. These are all 24 volt outputs to tell the motor what to do. Below that, we have a 120 volt EAC, that's electronic air cleaner terminal. Right below him, we have what we call a CIRC terminal. Now, that CIRC terminal, what that is, that's the continuous hot 120 volt power going to the ECM motor all the time. Remember, all of our high efficiency motors are powered up all the time, and then we command them what to do with 24 volt inputs. Well, that's where it says CIRC. That's where we power that motor up all the time with 120 volts. Right below that, we have a 120 volt L1 terminal. That's where we bring in 120 volt to power up all of our 120 volt components. Below that, we have a XFMR. That's our terminal to power up the transformer, primary side of the transformer. Again, these are all 120 volt inputs, outputs. And then the HUME terminal, team, one more time, is a 120 volt humidifier terminal. This is an output to a humidifier. If you have a humidifier, you can power the humidifier up during a heating call of operation from this terminal. Below that, we've got our neutral blocks. And here we notice we've got about 5 terminals, and they're all kind of color coded on this one. They color coded them white for all the white wires, but this is where all of our neutrals come in. Now, as we come around the bottom of the board, we notice we have an output harness to the hot surface igniter and the inducer fan motor. Again, this is harnessed in from the factory. As we move to the left of the board, we see we've got our 12-pin harness. It's going to feature 24 volt inputs and outputs to things like our gas valve, pressure switches, and safety circuits will all be harnessed in right here. Here we have a 3-amp fuse for 24 volt onboard protection in the lower left-hand corner of the board as we see the board's oriented in our photo. Now watch this, team, right in the middle of the board to the right-hand side of the middle. So in the middle of the board to the right-hand side, there's our flame current pad. So it's in a little different position than our previous board. But as you can see that it still has the same function. 1 microamp DC is equal to 1 volt DC on your meter. So again, this is a very convenient place to find microamps with the furnace running. And again, normal microamp should be about 3.5 to 4 during normal running operation. Team, is there any questions or comments on the two-stage board layout? We had one real good question about staging a minute ago, but is there any other good questions or comments on the two-stage board featuring the TM8 and the TM9Y furnace control? Any questions or comments? Okay. Tell you what, with that, we're going to jump into module number 2. In module number 2, we're going to get into some more control board layout. And specifically, we're going to be talking about a two-stage variable speed control board layout and some flash codes with some interactive practice. Now, everyone should have some handouts that should have been shipped to you. And so we'll give everybody a chance to do a little interactive practice as we take a look at some flash codes. But let's take a look at that two-stage variable speed control board layout first, and then we'll talk about some flash codes as we kind of round out the afternoon with our training session this afternoon. So this time we're going to take a look at our two-stage variable speed board. Now this board will be found on a TM8 or a TM9V. And that V means it's variable speed. Now remember, team, if it says TM8, you know it's an 80% furnace. And if it's a TM9 in the model number, that means that's a 95 plus furnace. And in this particular case, the V on the end means it's a variable speed. So this particular board is going to be on a variable speed indoor blower. And it's going to have a two-stage heating capability as well as two-stage cooling capability. So again, an extremely versatile product. It'll match up with anything in our inventory except our 2021 SEER product. And so, and actually, if you have the right coil on it, you can go communicating on this as well. I forgot to mention that. So this board, it's a two-stage board, but it is communicating capable. So you can run it on like the 19 SEER communicating. And with the proper coil, it'll actually work on the 20 and 21 SEER momentum product as well. So again, a very, very versatile product. You can even hook it up to a single stage 13 SEER if you're in the northern climate. So an extremely versatile product. It's a great product. It has that high efficiency variable speed indoor blower on it. But just like before, team, we're going to start on the left-hand side as you take a look at the board. And we're going to talk about some of the variable speed functions as well. But let's go ahead and start on the left-hand side with conventional low voltage wiring. So this board is extremely versatile in the fact you can go with a 4-wire communicating thermostat, what we call our hex thermostat, or you can use your favorite Honeywell, Robert Shaw, or your favorite 24-volt thermostat with our 24-volt connections. And the board is smart enough to know if it's either communicating or 24-volt based on how you hook it up. So it's very, very intelligent board. So on the left-hand side, if you're hooking it up conventional 24-volt, C is our 24-volt common. And again, no pun intended, but that's very common in the industry. So 24-volt, C is 24-volt common. G is going to be your fan call from the thermostat. R is your 24-volt hot, again, very conventional. And because it's two-stage heating and two-stage cooling capable board, here we have W/W1, just like we had before on our previous board. If you're stuck with a single-stage thermostat, we can still give you some staging on this board with a jumper selection. But be sure if you have a single-stage thermostat, hook it to the W/W1 terminal if you're stuck with a single-stage thermostat. Excuse me, so W/W1 is our first stage heating call. Y/Y2 is our, Y/Y2 is our second stage cooling call. Again, it's a two-stage heat, two-stage cool capable board. Y1 is our first stage cooling if you have a two-stage product outside. W2 is our second stage heating call. Second stage heating call. Well, this board has a dehume function, a dehumidification function in the cooling mode of operation. So if you want to have, because it's variable speed, If you want to have a humidifier hooked up to this dehume terminal, it'll actually dehumidify in the cooling mode of operation. So that's a pretty cool little feature. This board also is configured for dual fuel right from the factory, and the fact that it has a O terminal if you have this on a heat pump. So that's kind of neat. So this furnace, it's smart enough to know if you have O terminal energized or O terminal enabled, it knows it's on a heat pump. And so if you do have it on a heat pump, just please remember you're going to have to put a jumper selection to tell the board it's on a heat pump, because it'll then look for the O terminal for the reversing valve on a heat pump if you have this on a heat pump, a dual fuel application. Any questions or comments so far on the low voltage terminal strips on our variable speed control board layout? Okay, let's jump to the top of the board. You'll see there's a fuse terminal, and I don't know why I don't have a fuse in the photo right here, but basically if you look at it closely, it typically comes with 3 amps, but at this particular board, it looks like you can actually go up to a 5 amp fuse on there. If you look closely, 5 amp maximum. So there's where our fuse is for our 24 volt onboard protection. As we move around the board, this furnace is communicating capable. So if you have it hooked up to a hex thermostat with a communicating system, it'd be 4 wires from the thermostat down to the furnace, A, B, C, and R. Have your tricolor LED right next to that communication terminal block. And again, it's red. It'll flash either red, yellow, or green based on the flash code. There's our last error button that works just like we did before. You can hold that last error button down in about 10 to 15 seconds and it will clear the memory. Or you can retrieve the flash codes by depressing it and watching the flash codes by retrieving those flash codes with the last error button. Now, this board has a CFM light. Because it's variable speed, we give you a CFM light. So once you set the board up for optimal airflow on whatever job you're on, you can then confirm that the board is programmed for a particular CFM by looking at the CFM light. And so it's just a real quick visual indicator of what the board is doing and what the blower is doing. It'll flash 1 time for every 100 CFM that you have set up on the board. Now, team, if you have the unit set up, if you've got the furnace control set up for communicating, we give you some optional temperature, auxiliary, and float switch terminals. You'll notice that there's another green block right there, and those terminals are going to be for auxiliary or optional temperature, auxiliary, and float switch terminals if you have it set up on communicating. If you have it set up for 24 volt, those terminals will not be in effect. This is strictly for communicating, a communicating system with optional devices if you have a communicating system. Any questions or comments so far? Everybody good? Okay, as we move around the board, we see we've got a 6-pin plug that goes down to our ECM motor. And by the way, team, anytime you see that term or we talk about that term ECM, ECM means electronically commutated motor. It's just a fancy name for a high efficiency motor. So any of our high efficiency motors are going to be a standard ECM motor where you actually have speed selections where you actually move a wire, or you'll have a variable speed ECM motor. It's also a high efficiency motor, but the board does a lot more control on it. So you don't have to move speed taps on this particular board. You're just going to make jumper selections, which we'll talk about in a little bit. But any ECM motor is a high efficiency motor. So when you see that term in any of our training material, when we're talking about an ECM motor, we're talking about a high efficiency motor. A standard ECM motor, you have to physically move speed taps on the motor. A variable speed ECM motor, you're going to make speed selections. You're going to make blower motor selections on the board with some jumpers or dip switches. That's the main difference between the two motors. So this is a 6-pin plug that goes down to the high efficiency variable speed ECM motor that takes 24 volt commands from the board down to the motor. So that's the difference on this compared to our previous boards we talked about. Here we've got a neutral harness, as well as some spade terminals, some extra spade terminals for extra devices on the neutral spades and the 6-pin plug. As we kind of move around to the side of the board, we've got a 5-pin plug for our hot surface igniter, our transformer primary, and our high and low inducer. So it's all harnessed in on this particular board. They're not terminals, they're actually harnessed in for your hot surface igniter, your transformer, and your induced draft blower high and low speed. Below all of that, you've got a humidifier terminal. Again, this is 120 volt output. Anytime you have a heating call, you'll output 120 volts on this board to run a humidifier if so desired. Right below the humidifier terminal, you have an EAC terminal. Again, this is for a electronic air cleaner. And it should be noted, team, anytime you have a G call, or in other words, anytime the fan is running, you'll have 120 volt output on this terminal EAC to run an electronic air cleaner anytime the fan is running. Along the bottom of the board, we have our flame current pad. You'll notice it's at the bottom of the board on this particular control, but it's the same thing, team. 1 volt DC is equal to 1 microamp flame current. Same thing that we talked about before. There's our 12-pin harness. It's going to have inputs and outputs to our gas valves and our pressure switches and so on. That's all harnessed in from the factory. Now this is where we start getting a little bit different with a variable speed board. The variable speed board, again, is going to have everything harnessed in, and you're going to make speed selections on the fan motor based on jumper selections. So on the variable speed, we have what we call a delay jumper. This delay jumper allows us to adjust the fan speed and some ramping operation based on your local geography. So if you take a look at your install information, you'll notice that this delay jumper, we can select it for a humid profile. You know, like down here in Mobile where I'm from, if you select a humid profile, it'll slow the fan down during the cooling mode of operation to take extra humidity out of the air. Or if you're in a real dry climate, like out in Arizona, you don't want that slow running fan. You want it to run at a higher speed and so on. So based on your local geography, look at your install information and you can see that there's different fan delay profiles, cooling fan delay profiles to help give you extra comfort. And so that's what that delay jumper is all about. Now, please make a note of this. There's 2 jumpers on the board that work together. The adjust and the cool jumper works together to give you your cooling airflow. Cool and adjust work together to give you your cooling airflow. And actually in your handout, or if you have a workbook, if you put a workbook together or in your handouts, you'll notice on page number 36 of your workbook or handout, you're going to see that there's going to be some jumper selections that you can select as you take a look at the service information. Excuse me. Please remember the cool and the adjust jumpers work together to set up or to program your cooling airflow. Now, please write this down, everyone. You're going to set up this board based on the tonnage of the outdoor unit. So the cool and the adjust is your cooling airflow. You're going to set that up based on the tonnage of the outdoor unit. Now, please write this down. You always want to set your airflow up on these variable speed products for 400 CFM per ton of cooling. 400 CFM per ton of cooling. So if I have a 2-ton unit outside, I'm going to want to make sure and set the cool and adjust jumper up for 800 CFM on a 2-ton unit. If I've got a 3-ton unit outside, I'm going to set the cool and the adjust up for 1200 CFM and so on. So you get the idea. So we always want to set our variable speed control boards up on our variable speed furnace and our variable speed air handlers for that matter. If you have a variable speed air handler, you want to make sure and set them up for 400 CFM per ton of cooling based on the size of the outdoor unit. Any questions or comments on setting those jumpers up or the amount of airflow that we would require based on the tonnage of an outdoor unit? Any questions or comments on that? Okay, well, good. So cool and the adjust jumper, they work together to set up your cooling airflow. Right below that cool jumper, you have a heating jumper to adjust your heating airflow. So again, look at page number 36 in your handout or in your workbook, and you'll find that on page number 36, there's a jumper selection called heat. And so based on your furnace, based on the size of the furnace you have, you'll select your heating airflow based on the size of the furnace. In addition, from a service standpoint, this is something we always want to double check to make sure we don't overheat the furnace, and based on the ductwork. So what we're going to do, you're going to check your temperature rise on the furnace, and then you can adjust that heating jumper either up or down to provide the proper temperature rise on the furnace when you commission or set the furnace up. Just above that and next to the cool jumper, you're going to find there's a humidistat for cooling. And so if you want to use that dehum terminal that we talked about on a 24-volt terminal where it says dehum, if you want to utilize that humidistat for cooling, you're going to go yes. You'll go yes. And if you put that jumper in the yes position and you have a humidistat hooked up to the dehum terminal on the low voltage terminal strip, team, what will happen in the cooling mode of operation, if it's humid in the house, and this is in the yes position, and you have a humidistat hooked up the dehum terminal on the low voltage side. If it's humid in the house, it'll slow the fan down to about 80% airflow during the cooling mode. And then when the house dries out, if it's humid in the house, it'll slow the fan down. And then once it dries out and the humidistat closes, click on a drop of humidity, it'll allow the fan to go to full speed. So what this does, this dehum terminal or this dehum jumper works with the dehum terminal and a humidistat to dry the house out, or if you have a humid situation, you can use this to get extra humidity out of the house during the cooling mode of operation. So it's a very nice little feature. Now, please make a note of this. If you're not going to utilize this feature, make sure that jumper is in the no position. If you're not going to utilize that dehum feature, make sure it's in the no position. That way you'll make sure and you'll have 100% airflow. Because remember, team, if I have this in the yes position and nothing hooked up to the dehum terminal over on the left-hand side there, the fan will only run at 80% cooling airflow. So be sure and put that in the no position. And by the way, no is the factory. We ship it on no. That's the factory position from the factory. But if it is in the yes position, you only get 80% cooling airflow if you don't have a humidistat hooked up to dehum terminal. Any questions or comments on that? Okay, right below that, there's the heat pump yes, no. And what that is, you're actually telling the board if it's on a heat pump or straight cooling unit. So if it's in the yes position, it's going to be looking for voltage on the O terminal in the cooling mode on a heat pump. But if you have this furnace on a straight cooling outdoor product, make sure that jumper is in the no position, because the board needs to know if it's on a heat pump or a straight cooling unit. Here we have fan speed. That fan speed is for continuous fan, high, medium, and low. High, medium, and low. So this will determine how fast the fan will run if the homeowner goes to the thermostat subbase assembly and goes to fan on. If they go to fan on, the fan will run either high, medium, or low. Now, please write this down. This is a percentage of cooling airflow. Percentage of cooling airflow. And so write this down. Low is going to be about 35%. Low is going to be about 35% cooling airflow. Medium will be 50% cooling airflow. And high will be 100% cooling airflow. So on this particular board, we give you just a high, medium, low in those, but it's a percentage of cooling airflow. So low is going to be around 35%, medium 50%, high will be 100% on continuous fan operation based on that jumper selection. Right below that, you're going to find it says blower delay jumper is used for heating off delay. And what this is your heating off delay selection. So how long the fan's going to run, When the call for heating goes away, when the thermostat's satisfied, is field selectable with that jumper right there. Now, it normally comes from the factory team at about 120 seconds, but it is field selectable from 60 to 180 seconds. In other words, from 1 to 3 minutes, based on that jumper selection, is your heating off delay. Finally, there's a heat staging. And please notice, team, unlike our previous board where we had some intelligent staging on the board, this board is strictly timeout. So if I'm stuck with a single stage thermostat, based on this jumper selection, will determine how long it'll run. The furnace will run on first stage before it goes to second stage. So if you take a look at it, this is a heating staging selection based on if you're stuck with a single stage thermostat. And if you look at it closely, the selection is 10, 15, or 20 minutes. So if you're stuck with a single stage thermostat and I get a W/W1 call from the thermostat, it's in first stage. If I have that jumper in the 10-minute, on the 10-minute position, the furnace will run 10 minutes on first stage, and then it'll go to second stage to complete the call if it hasn't completed the call in 10 minutes. So again, it doesn't have the intelligent auto function like we had on a previous furnace. This is strictly timeout on this board, 10, 15, or 20-minute timeout. Any questions or comments on any of the jumper selection before we continue or finish up our features on this board? Any questions or comments? Okay, well, the final feature on this board, team, is what we call a model ID plug. A model ID plug. This model ID plug, it must be installed on a replacement board. So what we're trying to say is this: every one of these variable speed boards has a model ID plug. It's just a little simple plug, little wired plug that what's going to happen, it tells the board what size the furnace is hooked up to. So instead of having 47 different boards, you know, we have this one variable speed board on both 80 and 95 plus furnaces, but that model ID plug tells the board what size furnace it's hooked up to. So if I have a replacement board, if I've got to replace the board, don't forget to take the model ID plug off the old board and then snap it onto the new board. And then as soon as you power it up, it knows that it's on, you know, a particular size furnace. So the model ID plug has to be installed on the replacement board. So if you have a replacement board, don't forget to tell the technicians to take that model ID plug off the old board, snap it on the new board, and as soon as they power it up the first time, the board will know it's on a particular size furnace. So that model ID plug is important to configure the board to tell it what size furnace it's hooked up to. Any questions or comments on the variable speed control board layout before we get into some flash code diagnostics as we start kind of wrapping up and rounding out this afternoon training session? Any questions or comments on the variable speed board? All right, team, I'll tell you what then. Let's go ahead and talk a little bit about some flash code diagnostics. Let's do a few together as we talk through this. Now, it should be noted, in your handouts, you're going to have a couple pages in your handouts, page number 21 and 22. Page number 21 will be for single stage furnace control flash codes. Page number 22 will be for two-stage furnace control flash codes. And so what we're going to do, we're going to review some of those flash codes just to kind of give everybody a little bit of a taste on what those flash codes would look like out in the field. And so we're going to talk about single stage and two-stage control board flash codes. We're going to talk about some of the likely components to check. This is kind of an interactive session. And so we'll take a little bit of time looking at it, but at the same time, if you've got questions or comments, please say something about it. Again, page 21 and 22 in your handout or your workbook will be where you're going to find these flash codes. So we'll give you a little bit of time to look at those flash codes as we talk about them and where we'd see that on our control board. Finally, we will talk about there is a flash code or condition that when to replace the control board. You don't have to go any further. If you get this particular flash code or lack of flash code in this case, you'll know that it'll be time to replace that control board. So let's go ahead and do a few together just to make sure everybody knows where to look in their workbook or in their handouts as we take a look at some control boards. So the first one we're going to look at is a single stage control board. A single stage control board. This is going to be found on a TM8 or a TM9E. And we see right now that it's an amber color, but let's go ahead and see what it has to say. It's a continuous amber flash. So what that means is this. So even though we're not flashing on the screen, we see it's an amber flash. If you take a look at your page number 21 with a single stage control board, you'll see a continuous amber flash. Now, if you take a look at the information, there's going to be two different amber flashes specifically. It'll say like a 3 flash, 4 flash, whatever. But if it says continuous or fast flash, so what does a continuous amber flash mean? In other words, it's flashing continuously. It's not pausing like a flash code. You just have a continuous amber flash on this single stage board. What does that mean? Anybody, go ahead and unmute your mic. What does a continuous amber flash mean? Page number 21. All right, team. Well, a continuous amber flash is low flame current. Low flame current. So if you have low flame current, it'll give you a fast, continuous amber flash. And that the most important thing about low flame current, the very number one cause for low flame current is poor grounding. So make sure that your ground is very, very good on the furnace. And what I mean by that, you have to have a good solid ground all the way from the power panel over to the furnace. So make sure that if the furnace is hooked up, especially in an older home, you might not have a real good ground, but you have to have a very good ground in order for that flame current to work. So some of the things you want to check is make sure you have good grounding, and then make sure the flame sensor is clean. If the flame sensor is dirty, make sure that you clean that flame sensor. I like to use Scotch-Brite or stainless steel wool. Do not use sandpaper. We recommend that you use Scotch-Brite or something like that, or stainless steel wool to clean that flame sensor, or replace the flame sensor if you have low flame current. So grounding is very important, and make sure you have a clean flame sensor. And then check your flame current. Again, go down to your flame current pad, and you should have about 3.5 to 4 is normal flame current. If it drops below 1.5, it'll start giving you that amber flash code that we're talking about right now. So normal flame current about 3.5 to 4. And then of course check your gas flow as well. Make sure that the gas pressure is set properly, and that you have a good high quality flame. Otherwise you won't get good flame sensing. And finally, sensor location. Make sure that sensor is centered in the flame like it should be. It's not bent to one side or what have you, because that can give you erratic flame current as well. Okay, any questions or comments on that continuous flash? Jill, we're going to have you check one more time. Audio still coming through okay?
Yep, we're doing great.
Okay, good. All right. Thank you for doing that, by the way. Okay, our next flash code, we have a steady on LED, a steady on LED. And so it's not flashing, it's just steady on. And if you take a look on page number 21, again, that's for your single stage control board. A steady on LED tells us something's going on with the board. So some of the things we're going to check if we have a steady on LED would be, number one, you're probably going to want to recycle the power, because if it's steady on, it means the board has failed its internal electronic check. And so I always like to cycle the power to see if it'll clear itself. And if it doesn't clear itself, if you have a steady on LED, then at that point just replace the board. And so a steady on LED, that means the board has failed something internal to its electronic circuitry. And if you have a steady on LED, I like to recycle the power at least one time, shut the power off, count to 10 seconds, turn the power back on, and see if it'll clear itself. Sometimes it'll clear itself. But if it's steady on, then you know that it's the board has failed internally. It's electronic circuitry, and so it's time to replace that board if you have a steady on LED. Tell you what, let's take a look at a two-stage board. A two-stage board, you're going to find a two-stage board on page number 22 of your handout. And on this particular two-stage board, it's a red flash, and we're showing you that it's flashing 13 times. 13 times. So as you take a look at your control board and you count those flashes, it'll count, 1, 2, 3, 4, up to 13 in this example. Then it'll pause for about 2 seconds, and then it'll keep repeating itself. Flash 13 times, pause for 2 seconds, flash 13 times, and so on. So when you're reading those flash codes, team, remember there will be a pause of 2 seconds in between those series of flashes. So in this case, we've got 13 flashes, page number 22 on your handout or your workbook. And let's check the following if we have 13 flashes. What it's telling us, that 13 flashes tells us we have a high fire switch is open when it should be closed. So some of the things we want to double check, we want to check our vent pipe to make sure it's not obstructed. Because remember, team, if our vent pressure switches are not closing when they're supposed to, we might have a problem with our vent pressure. And so check your vent pipe to make sure it's not obstructed. You don't have any critters, or you don't have any, debris in that vent pipe. Make sure you check your vent pressure. And we'll actually talk about checking vent pressure in one of our other modules in a few days when we go to do module number 3 and 4. We'll talk about how to check vent pressure. But when you check vent pressure, you want to make sure that it's going to fall within the proper parameters. And so if you don't have the proper vent pressure, that switch isn't going to close, and it's going to throw this flash code. So it's important that, again, when we take a look at the flash codes, now remember, team, all of these flash codes, it just kind of guides you in places to look. And so any questions or comments so far on where we're finding these flash codes and some of the common flash codes that we've talked about so far? Any questions or comments? Okay. Well, let's take a look at another single stage control board. Again, you'll find this single stage board on a TM8 or 9E product. And this is an amber flash. It looks like we've got an amber flash again. And this amber flash is a slow, steady amber flash. Slow, steady flash. And so unlike the one we had a little bit ago that was fast, continuous amber, that was low flame current, we find that's just a slow, steady amber flash. In other words, it's not pausing for 2 seconds. It's not giving us a flash code. Just a slow, steady flash is actually good news, because some of the things we're going to check, if we have a slow, steady flash, we automatically know that it's normal operation. And so we wanted to show you normal operation too. So a slow, steady flash is a normal operation. And it tells us that we have a W call. It tells us that it's gone through its normal sequence of operation, and we'll talk about sequence of operation in module 3 and 4. And it's gone through its normal sequence of operation. It's passed all of its own internal electronics checks and so on. And so normal operation with a slow amber flash. Any questions or comments on that? Okay. Again, if we have a slow, steady flash, it means we have a call for heat and the board is operating normally. Here we have 2 red flashes. So as you take a look at page number 21, this is a single stage board. We have 2 red flashes. 2 red flashes. And if you take a look at page number 21, you find the 2 red flashes. Some of the things we need to check: 2 red flashes are going to tell us that the pressure switch is stuck closed. And so pressure switches normally don't stick closed, but if they are stuck closed on initial call for heat, it's going to give you a 2 flash code, 2 red flashes. Now, it might be you had someone out there, maybe a technician was messing around with the wiring and he maybe jumpered something and he forgot to repair that. So double check the wiring, make sure you know that we don't have a wiring issue on the switch. Maybe someone forgot a jumper. Maybe a technician was out there selecting or checking out a pressure switch and he jumpered the pressure switch and he forgot to take his jumper off when he was done. Because if you have a switch that's closed when it's supposed to be open during initial call for heat, it'll give you that 2 red flash code. And so if someone forgot a test jumper and the furnace fires off after the test and that pressure switch is closed electrically when it's supposed to be open in the normal sequence of operation, it'll give you a 2 red flash. So maybe someone forgot a jumper. So make sure that you look at the pressure switch, that there's not a jumper on it, and that it hasn't been wired in such a way to try to jumper the switch. Because remember, team, on our Champion furnaces, if you jumper a pressure switch on initial call for heat, what'll happen, it'll throw this flash code. So it knows if that switch is open, it knows if it's closed or if it's been jumpered. So by all means, look at that. Maybe someone forgot a jumper if they were out there testing it. Any questions or comments on some of our basic flash code interpretation and where we find it on page number 21 and 22 in our workbook or handouts on our flash codes? Any questions or comments so far? Okay. Well, team, I'll tell you what, that concludes our module number 1 and 2. Let's go ahead and open up our mics and take the opportunity if there's any final questions or comments. But we want to thank everyone for your attendance today on our training, our gas heating module number 1 and 2. But let's open up the floor and unmute your mics if you've got any final questions or comments before we secure for today. Well, Jill, we've got a pretty quiet crowd today.
Yeah, quiet group today. That's all right. I'm sure they learned a lot. So we will have the follow-up to today's session next Tuesday, the same time. I will resend the invitation out to everybody again, just to make sure you have it and you'll use the same handouts. And then we have also sent a list out of Joel's other classes that will be led for the remainder of this fall. So I'd love to have people join in on those as well. So thanks, Joel. Glad to know you're safe and you've gotten all cleaned up from the hurricane.
Yes, we're working on it. We haven't got everything done yet, but we're definitely working on it. And thank you so much for setting this up for us, Jill, and everybody on this call today. Thank you so much for the opportunity to train with you. Please have a great day. Stay healthy, stay safe, and we'll see you next week. Have a great day. Thank you. You bet. Bye.